Okay, before we start working out how to integrate exponential functions, I want to talk about how to differentiate them. Okay, e to the ax goes to ae to the ax. Okay, so what we've done, the power hasn't changed. So that's differentiating. So the same thing's going to happen with integration, because to reverse from here to here, the power stayed the same. Okay, so we want to actually be able to leave that power the same. So the power doesn't change. However, what we did do when we changed it was we must have divided by that a. Okay, so we need to integrate, we need to leave the power alone, divide by a plus c. So e to the 5x would have gone e to 5x over 5. Think about it. If you differentiated e to the 5x, it would times by 5, and then 5 divided by 5 would be 1, so you'd get what you wanted. E to the negative 4x divided by negative 4. Now most of us don't like to write dividing by negative 4, so we'll put that negative up at the top. Okay. E to the 2x minus 1. Well, let's think about it. All you need to do is you need to say, hey, look, how did I get from here to here? Alright, sorry. How did I get from e to the a function, so here's the function, e to the 2x minus 1. Okay, that's what I want to differentiate to make. So what went up to make that? Okay, well, remember the power doesn't change. So if I differentiated this, I'd get just a 2 in the front. So I'd better just divide it by 2, and that differentiator would give it. It's basically trying to logic out what would differentiate to make that. Okay, and you'll find every single time if you have e to the kx plus c, it will end up being e to the kx plus c over k. That'll always happen. K plus your constant. We'll call that phi. This last one, e to the 3e to the negative 2x. Just rewrite it. Okay, now it's really simple. It becomes e to the negative 2x divided by negative 2, so the negative will go in front. 3 stays the same, plus c. Alright. So the logic again is you're trying to find a function that would differentiate to make the function that's in the integration. So this here would differentiate to make that. This here would differentiate to make that. Okay, all of them. It's going to happen that way. Okay.